In this presentation, we'll talk about the mediator pattern. The force behind the mediator pattern is really to decouple and avoid the violation of the open-closed principle. Let's understand what this pattern does first of all. This pattern focuses on a group of communicating objects, and its goal is to reduce the coupling between them and make it easier to extend some rules. While it's trying to reduce coupling in one area, it often ends up increasing coupling in another area, and that is one of the consequences of this pattern. So it's more of a sacrificial object that takes on more coupling so the rest of the classes can have reduced coupling. Let's understand what this is, and then we will look at a couple of different examples of this. The first thing is mediator pattern defines an object that encapsulates how a set of objects interact. So the idea behind mediator is to really take a set of objects and take away the interaction between them and encapsulate that interaction into a mediator object. So mediator promotes loose coupling between objects from referring to each other explicitly, and it lets you vary their interaction independently. So the idea behind mediator is to take objects that have to work with each other and relieve the burden of the dependency from them. Let's consider two examples of this, one in concept and the other in code. Let's say for a minute a group of people are working together. Well, in the middle of the afternoon, Joe wants to take a quick break and wants to go run some errands. Well, what should Joe do? Of course, Joe cannot just disappear, has to make sure there are enough people there to cover the work, not cover up the work. Well, in some cases, depends on the job, of course. Well, to cover the work. So what would Joe do? Well, Joe would have to go to every single employee and say, I want to go ahead and run an errand. Is that okay for you? Do you need anything, or can you take care of this? And let's say we have 15 employees. Well, unfortunately, Joe would have to go talk to each and every 15 employee before Joe can go run the errand. Well, in a few minutes later, Sarah wants to go, but can Sarah go or not? And maybe Bob wants to go as well after a while and take care of something. In the meantime, how do we really ensure there is enough people to take care of things? Well, you don't want everybody to communicate with everybody else. That would not be a very effective communication. The more people you have to communicate, the more overhead it is. So how do we solve this particular problem? Well, we would typically come up with one person, let's call them the supervisor. And what does a supervisor do? The supervisor coordinates between all the employees. And so Joe, instead of going to every single employee, goes to the supervisor and says, hey supervisor, I want to run an errand. Can I go for 2 hours? And the supervisor says, of course, Joe, go ahead and take care of it and let me know when you come back. Well, a few minutes later, Sarah walks over and says, hey, I need to run to the dentist. Can I go? And the supervisor says, yeah, that's fine. We got enough people to take care of it. Go ahead and take care of it, Sarah. Let me know when you come back. Well, a few minutes later, Bob goes to the supervisor and says, hey, I need to run over to the store to get something. Can I go now? And the supervisor says, well, Bob, if you don't mind, can you just wait for about 2 hours? When Joe gets back, you can go, because we need somebody on the floor to take care of things if any request comes in. So in other words, this particular supervisor acts as a mediator in this particular example. Let's consider another example we can look at the code level. Let's say we are designing an application for designing wheels, and the diameter of the rim is restricted to, let's say, the diameter of the hub. And the tire maybe depends on the rim's diameter, and spokes diameter is length is restricted as well. So in other words, there are rules that pertain to what the size of different things could be. How would we go about designing this particular code? Let's think about a few different options to begin with. Let's say for a minute, we are starting with a tire class. So I say tire equals new tire, and I'm going to say tire.setRadius, and I'm going to specify the radius to be 100. So let's put the tire in the accessories package. So let's go ahead and create the tire. Let's say we want to put that in the accessories. So we have a tire class on our hand. Let's go ahead and create the set radius for a minute. So we set the radius value here, but where do we go ahead and put the radius? Well, the radius is going to be setting the radius value as we can see right here. Well, it looks great so far at the moment, But let's go ahead and introduce a hub to work with. So we have a hub in this case equals new hub, and likewise we'll go ahead and create the hub class for our purpose, and the hub is going to reside in the accessories package as well. And now that given the hub, we want to set the radius of the hub. So we're going to say set radius, and let's say the radius of the hub is going to be, let's say a 20. Now we want a method to set the radius. So here is the set radius method. That's working out really well so far, but we got a small problem on our hand. We want to make sure that the hub radius is never greater than the radius of the tire, or the tire radius is never smaller than the radius of the hub. So how do we go about enforcing that? Let's first of all go ahead and display here the radius value. So in the toString method, let's go ahead and say return get class dot toString plus, let's go ahead and say a radius over here, and we will display the radius values. In this case, let's say the radius. Well, that's great. So we have displayed the radius in the toString method of the tire, and likewise we will display the radius in the toString method of the hub as well. So there we go, we displayed that value. Well, now that we have displayed the value, let's go ahead and display those two. So we will say tire, and we will also output the hub, and we can see that the values are what we set. But how do we enforce the rule? Well, to enforce the rule, we want to say that the hub's radius cannot be greater than the tire's radius, which means the hub has to know about the tire. So we could pass the tire here to the hub. But unfortunately, the tire's radius cannot be greater than, rather less than the hub's radius, which means we got to send the hub to the tire. Well, this is not going to be easy to do because we haven't created the hub yet. This also poses this cyclic dependency between these two objects right now that puts us in a little bit of a pickle. So what can we do? Well, we could pretty much come back here and say, well, why don't you create the hub and call maybe a tire.setHub and specify the hub? Well, that's one solution, a little nasty, but that could work. But that still requires the tire to know about the hub and the hub to know about the tire. Let's say a little bit later, we decided to introduce, let's say a spoke object. So now I have a spoke, and let's say spoke, and we would typically have a collection of spokes, but let's keep it really simple here. We'll just work with one spoke. Now that we have a spoke, I want to say over here, spoke.setSize, and I'm going to specify, let's say, a size of 80, but there's a rule that the spoke size cannot be uncontrolled. It has to depend on the size of the hub and the size of the tire. Similarly, when you change the size of a tire, you have to be concerned about the size of the spoke as well. So now we have a bigger problem. The tire has to depend on the hub and the spoke. The spoke has to depend on the tire and the hub has to depend on the tire and the spoke. Now introduce a fourth object. You see where this mess is going to lead to. We're going to get an n square dependencies in the code. And certainly n square dependency is not going to really help us with a good design. So what can we do to avoid that particular problem? Let's first create the spoke class over here, and then we'll come back and address that in just a second. So in the spoke, we're going to have a set size, and that's setting the size as well. So far, so good. Now let's remove these tight coupling we just talked about, where the tire should not depend on the hub and the spoke. However, the set radius of the tire should be concerned about the size of the hub and the spoke. So how are we going to manage all these changes without increasing the coupling? Well, to manage all of these without increasing the coupling, or the n square coupling, we're going to introduce a wheel class. So here is our new wheel, and the wheel becomes a so-called mediator for us. So this wheel here is the mediator, and the hub, the spoke, and the tire know the mediator, and the mediator knows about each one of them. What we did in a sense is we converted from an n square dependency to an order of n dependency. So rather than hub depending on two classes spoke and tire depending on two classes spoke and hub, and so on, we simply said all these will depend on the mediator wheel and wheel will depend on each one of them. So it's a trade-off. Sure, wheel is tightly coupled to the other classes, but that's less coupling compared to the tire depending on two other objects and each of the other objects depending on each of the other objects that they need to communicate with. So we created a wheel class in this case, and we will put that into accessories as well. And now that we have a wheel class, let's go ahead and do some work here. In the tire creation, we're going to specify what the wheel is. So let's go to the wheels over here, and we will set the wheel is equal to the given wheel, but the tire also says wheel dot set tire and specify the value of this. Well, the wheel is going to be the field within the class, and now we are going to specify a set tire, which is going to store the tire in the wheel class. Now the wheel class, of course, has a set tire that shows a reference to that tire. Likewise, what we are going to do here is we are going to go over to the hub class and then the spoke class and work through it. So in the hub class, we store a wheel, and in the spoke class, we store a wheel as well. Let's go ahead and implement the constructor of the hub, and that's going to set the wheel field, and then it's also going to say that the wheel better know about the hub as well. So set hub, and this is going to be a this. So we need a set hub method in the wheel class, and we just did that. Likewise, we're going to go back to the spoke class, specify the wheel for it, and that's going to be stored into a field. And then we are going to say here that the wheel dot set spoke, and in this case, of course, we're going to specify this. In reality, it's probably going to be set spokes, but this is good enough for our little example for now. So we have set that field right there, so all of them know about each one of them. Let's go back to the radius methods and change it a little bit. So we are going to specify over here. Let's go ahead and say, rename this for a minute. Let's go ahead and rename this as, let's go ahead and call it as change radius for a minute. So the change radius, and likewise, this is going to be a change radius method as well. So let's go ahead and change it to change radius. And then this is going to be a method which is called change size. So we have the change size method. But we'll make each of these methods as a Boolean method in just a second. So we are going to display over here the size, which is the spoke as well. So let's go ahead and display the spoke size. Let's go ahead and implement the toString method on the spoke real quick, and then we'll come back and continue further with this. So here is the toString method of the spoke. We return, in this case, the class information that we have on our hand, plus we will specify the size and display the size details for this. So now that we have all this code, let's go ahead and run it, and you can see in this case the values are as appropriate. However, what if we try to modify the size of the tire? So I'm going to say tire.change over here, and this is going to be change the radius, not range. So this is going to be change radius. So change radius, and we're going to change the radius over here to a new value. Well, what is the value I'm going to change the radius of the tire to? I'm going to change the radius of the tire to, let's say a value of 10. Well, that's not allowed because the radius of the tire should not be less than the radius of the hub. If I run the code right now, you can see it's broken. It is a 10, but that shouldn't be the case. So what I would like to do here is I want to output a false if we try to change the radius of the tire. So we'll make it a Boolean function for now, and we're going to do something a little different in here. We're going to create a method, a non-public method called setRadius, which is going to take the radius value. So we'll say radius, and it simply sets the field radius to that particular value right here. So this is going to be radius equals radius. But notice it's not a public method. We cannot call it from the outside. So what are we going to do here? We're going to simply return wheel dot set a radius, and it's going to set the radius for the tire, and then so that's going to be a this, and the new radius value that we're going to provide to it. So let's take a look at the set radius function of the wheel for a minute. The set radius of the tire for the tire says, well, if we have a hub is equal to null, or if the hub is not equal to null, but its radius is less than the given radius value, then go ahead and do the work. So we will simply say if that is true, then we will say a tire dot set radius, so set radius to the new radius value, and we return a true. Otherwise, we're going to return a false. So the set radius method says, if you try to set the radius of the tire, I'll check with the hub. If the hub is okay, I will let you change the value. If not, I will reject it. So now if we go back and run the code, you can see in this case, it gave us a false and the value remained at 100, which is a good news. Likewise, we could specify the set radius for the hub. So if I go to the tires, so let's say set radius for the hub, and I'm going to change it to, let's say, 110. Well, no, you cannot make it bigger than the value for the tire, but how do we enforce that? So I'm going to go to the change radius. We'll make it a Boolean method again, and this simply says return, and we will say wheel dot set radius, and this is going to be for the current value, which is the hub, and the radius value we are interested in using. So for this purpose, we're going to go to the wheel and we're going to implement the set radius method, but the set radius method in this case is for the hub, and so this is going to take in a hub. What does that do? It says if the tire is equal to null, or the tire dot radius is greater than the given radius, then go ahead and say the hub dot set radius is that and return a true. So for this, of course, we need a set radius method on the hub. So we will provide a void set radius int radius, and this is going to simply set the radius value. So that's going to be a simple set of the field is equal to the radius. So now that we have done all of this, if we execute the code, you can see it returns a false, and the radius, hub radius, is still at 20. So that's gone so far so good. But what about the spoke size? Well, before we get to the spoke size, let's go to the wheel, and we will say, well, when you change the radius of the tire or the radius of the hub, you also have to make sure you set the value for the spoke properly. So we are going to go back here and say spoke over here dot set radius size, and we're going to specify in this case it is going to be the difference between the tires get radius minus the tires hubs radius as well. So we'll say, go ahead and say get radius. So that is going to be the radius of the size of the spoke, and we do this in both of these cases. So now that we have done that, let's go back to the spoke itself to take care of this particular function. So if we go to the spoke, we can see that in this case we have a void set size, which is going to take the size value. So we'll say int size, and here we will simply set the value size is equal to the given size. Now let's go to the change size of the spoke itself. The change size of the spoke says return, and in this case wheel dot set size of the spoke, and then the size we are interested in setting. If we go back to the set size of the wheel, what does that do? That says, well, first of all, if, then I want to return a true, otherwise else I want to return a false. So we'll simply say return false. Well, what is going to happen within the return true part? Well, in this case, of course, I'm going to make it a Boolean function, and this is going to be the function to set the size. And what am I going to do here? First of all, if the tire is equal to null, well, if the tire is null, what can I do? Well, if the tire is null, in this case, I can go ahead and set whatever value I want to, and I'm going to say and, or I'm going to say if the hub is equal to null, so that's okay too, or then I can say if the set size, so it's got to be within the range, so I'm going to say tire dot, in this particular case we got to say the radius minus the hub dot radius, and if it is equal to the size, then it's perfectly okay to change the size. So I'm going to say spoke dot set size, and that's going to be the size value given to us. So otherwise, do not change the value of this. So far so good. We are setting the size based on these values. Let's go back to the spoke and make sure spoke is happy with this. So we are calling the set size method. And what does that do? Well, it says method cannot return a value. Well, of course, this is going to become a Boolean function. That's good. So if we go back and run this code, we can see that the values are what we expected so far. However, what if I were to say output spoke is equal to change size, and we're going to say, oh, what should the size be here? Let's say I want to say the size is 50. If I run this code, you can see it gave us a false, and the value of the size is still 80, so that takes care of that. One final thing here, if I were to now, after displaying this, I'm going to go back and do this one more time, but this time around, I'm going to say that the tire dot change radius to 200 instead of 100. Well, when I run this code now, you can see that the 12080 became 220 180, so that increased the size. And the beauty of this is the tire that we have on our hand has absolutely no dependency on the hub or the spoke. So if you introduce a rim tomorrow, you don't have to really change the tire for that. So likewise, the hub does not depend on the spoke or the tire. So if you introduce a rim, it will not fail the open-closed principle. Much like that, the spoke does not depend on the other objects, so it will not fail OCP if you introduce a new object later on. However, all this comes with the sacrifice of the wheel now being tightly coupled. So tomorrow, if you introduce a new type of object, let's say a rim, it will affect the wheel, but it's a sacrificial object that we are using so that the other objects don't have an end-to-end dependency or n-square dependency overall. So a set of objects want to communicate in a complex, well-defined way, but you want to reduce the interdependency between them. By reusing this object, you are by removing this dependency in this object, you are making it easier for you to extend and introduce new objects. But there are some caveats to doing this. First of all, reusing the objects can become very difficult now. Well, let's understand what we mean by reusing the objects is difficult, and we will talk about how to solve that. Let's say somebody comes over to you and says, hey, I've got a question for you. Could I reuse the tire in another application, let's say? Well, sure, you can use the tire in another application. Here you go, and you give them the tire. What does the tire want? The tire wants the wheel. Well, okay, we can give them the wheel, they can reuse it, but what does the wheel want? Well, the wheel wants all of them, the tire, the hub, and the spoke, and the rim, for example. So because of this cyclic dependency, we are going to be in trouble. This is not very reusable. It also fails now the acyclic dependency principle. If you think about it, the wheel depends on all the three, and each one of them again depends on the wheel. So we have a cyclic dependency. So what do we do to remove this particular problem? Well, to remove this particular problem, what we could do is we could first of all specify potentially a particular interface, if you will, and we can create an interface that says, I want to depend on an interface of a wheel rather than an implementation of a wheel. So the tire could depend on a wheel interface, and likewise we could make the hub depend on a wheel interface. Now the question then is, what happens to set tire and set hub? Well, those could become dependent on a component of some sort. So we could create an accessory hierarchy, for example. So in other words, what we could potentially do is we could create an abstraction on top of this. We'll call it as a component, and hub and spoke and tire could implement component, and we will raise the mediator as an abstraction or an interface. So once we create an interface called wheel, that implementation could have all the details. So for example, we could say wheel implementation implements, let's say, in this case, we'll say wheel, for example. So that would require us to create a wheel implementation. Let's actually refactor this first of all. So we could say, for example, in here, we have the wheel class standing in front of us. Let's make sure this code is compiling before we make changes to it. Well, let's go ahead and fix this. So this is going to be the size that was brought in. Great. All right. Now that we have fixed that code, let's go back and retry what we are trying to do here. So if I go to the wheel, I could rename this as wheel implementation, if you will. And so we have modified that to a wheel implementation. What about a tire though? Well, a tire will still depend on a wheel and not a wheel implementation. So we want this to be a wheel and not a wheel implementation. So actually let's back out of that change for a minute and let's go back to the wheel class, and it's still a wheel, but let's go ahead and introduce a new interface in this case. So we will go ahead and say implements, we'll call it as wheel interface for a minute. So we introduce a wheel interface, and the wheel interface, we can rename it after a while. That's going to be an interface we're going to create that the wheel is implementing from. Well, the wheel interface is what all these other classes would extend from rather than extending from a wheel implementation. So let's go ahead and implement the wheel interface. So create an interface called wheel interface. Great. Now we will go back to the wheel and we will rename that, first of all, here as wheel IMPL. So we will change it to wheel implementation, actually. So to make this a little bit easier, let's go to the tire and say this is going to be wheel implementation, not a wheel itself. Well, once we have a wheel implementation, this requires a set tire. Well, if the wheel interface has a tire, that in turn is going to result in a cyclic dependency. So to avoid that, what we could do is we could specify maybe a component interface right here. So we could say implements and we could say component. We could say wheel component. What about that? So wheel component could be an interface. We could go ahead and create it. So once we have a wheel component, this would in turn become set component, and this would become a method on the wheel interface. So let's go ahead and implement that component on the wheel interface. Now what's going to happen? Now that we have a component, this would of course become a component. So we'll say component, and this is going to be a wheel component rather. So wheel component, and this is going to become the component we are interested in setting. Now that we have a component, we can see in this case, this again would become a method on, well, this is on the tire class. So wheel.setRadius on this, and we could say this could become a set method, if you will, and it's going to be this and radius value we are interested in setting. Once again, this could become a method we are going to create, and this would become a wheel component. So we'll say wheel component, and this would become a component. So where does this take us? It's going to become a little bit more flexible. So component, and this is going to become the value, let's say. But of course, we got to say what value we are setting, because it could be multiple different fields, but let's worry about that later. So in this case, of course, now we have taken the tire and made it depend on the wheel interface. Likewise, now we can go to the wheel class and we can say, well, here is the set tire, but what am I going to do with the set tire? That becomes a function in the wheel class itself, but we can provide a set component method, which is the method that the set wheel interface is expecting, and then we could specify here, for example, a component, and this would become the component we are interested in. Again, that's going to be the wheel component that we are interested in. So now we can say in this case, when we have the component, we can say if the component is an instance of the tire, then we could simply say set tire, and then we could say tire, and that becomes the component we are interested in setting. So that brings us back into the wheel implementation with that particular method that we are interested in using. Likewise, what we could do is we don't actually need a get tire, so we can remove that. We don't need the get hub, and then we don't need the get spoke also. Well, what about the set radius? Well, now we have yet another method, which is the set value. So we could say public void set value, remember the wheel interface now has a set of a value. So we will simply call a set, and the set method, what does that do? The set essentially takes a component. So we'll say wheel component, and then we will say component, and then we'll say value that's being provided. Once again, we could specify here, this would be a Boolean, of course, and we would say in this case, we would simply say if the component is an instance of tire, we want to simply say set a radius. And what would be the value we specified to set radius? Well, remember the set radius method that we have here takes a tire as a parameter. So we'll say component, comma, and then the value that we have on our hand becomes the value for the radius, and we will simply say return that. Otherwise, simply return a false. So you can see how we can take the set method, which is generic, and turn around and call this. But all of this is in the implementation. Likewise, we could go into the tire class we said. Similarly, let's go into the hub class. And in the hub class, we will say this is going to be a wheel implementation, or rather interface. And so as a result, this becomes a set component. And we will also specify this implements the wheel component. So wheel component. And what does that do now? Well, this is no longer going to be a set radius, but simply a set. And of course, that complies to all the expectations of the hub. Likewise, we'll go to the spoke. And in the spoke, you will say this implements, this is going to be the wheel component as well. And we can specify that this is going to be a wheel interface. And as a result, this becomes a set method on the set component. And this is going to become the set method for the value. And our spoke doesn't have to change further. Now that we have done all that refactoring, let's go back and do one final refactoring. We can say this is not going to be a wheel anymore. We will change this to a wheel implementation. And then, of course, what we can do finally is we can change this one to simply a wheel instead of a wheel implementation. So that changes that as well. Now, if you go back to the tire depends on the wheel, which is an interface. That is good. And the wheel implementation implements wheel, and that is good as well. And our sample now, of course, uses a wheel implementation. But in this case, of course, we could simply say a wheel if you want to. And this is going to take a wheel. Well, obviously, this guy wants a specific implementation, the wheel interface. Let's go back and look at the tire for a minute. And if you look at the tire says I need a wheel. And of course, in the sample, we have created a wheel object, which we're going to pass. Well, he's complaining he doesn't have a clue what a wheel is. Of course, that comes from the accessories, and we will do the import on that. So we can just import the accessories. Let's say import accessories dot, let's say accessories dot tire, or rather a wheel. So we got that in. So that satisfies the compiler right there. What about the hub? Let's go to the hub similarly and say, hey hub, you need to talk to the wheel and not the wheel implementation. So that talks to the wheel, and so everything is fine for the hub as well. And finally, the spoke should be talking to the wheel and not the wheel implementation. And you can see that it's happy with that as well. So that takes care of that. So what did we do essentially? What we did essentially is we created a wheel component, which is an interface. And so the wheel component is sitting at the top. We also have a wheel interface, which is also sitting at the top. The wheel depends on the wheel component, but not on the tire or on the hub. So if somebody wants to reuse the tire, what's going to happen? We will give them the tire. As a result, we have to give them a wheel component, but the wheel component doesn't have any dependencies. That's great so far. Then in addition, we have to give them the wheel, but the wheel itself has no dependency on hub or spoke. So as a result, tire becomes more reusable. So we broke this dependency by using dependency inversion principle by introducing abstraction at the very top level. And the coupling is between the implementation and the class on the right side, but not between the interface and the classes. So we improve the reusability by going that particular route. So we can decouple. So what are some of the benefits of this? Behavior distributes between several classes must be customized without without a lot of subclassing. So what are some of the consequences of using the mediator pattern? Well, the first thing is it localizes the behavior that may otherwise be distributed among several objects. The wheel localizes all the behavior that could be spread out against tire and the hub and the spoke. You can subclass the mediator to change the behavior. If the rules change, go ahead and implement a new rule class and implement it from the wheel interface. It decouples the colleagues. Tire doesn't know the hub, tire doesn't know the spoke, and hub doesn't know the spoke, so that's a decoupling. It replaces n squared with n relationship. It replaces many-to-many interaction with one-to-many interaction. And finally, it's easy to maintain, extend, and understand this code because we have reduced coupling. We have not eliminated coupling entirely, but we have greatly reduced it. So how does this relate to other patterns? A facade and the mediator have some similarities between them. In the mediator, the colleagues know about the mediator. Notice how the hub and the spoke and all of that know the mediator, either the implementation or the interface. In the case of facade, the facade knows the subsystem, but the subsystem does not know the facade. Remember, a facade is simply a helper. The helper knows what it's dealing with, but the ones that it's dealing with doesn't know the helper. So colleagues may communicate with a mediator using an observer. We'll talk about the observer pattern later, but when a change happens in one of the colleagues, it may use an observer pattern to notify the mediator to say, hey, there's a change, go do something with it. We implemented that using the change method, and then we call the set method on the mediator, but we could have used an observer pattern to make that communication as well if we chose to. So that is basically what a mediator pattern is. The force behind the mediator pattern is to reduce coupling and to improve open-closed principle. And the solution we are using is to really move a many-to-many relationship to a one-to-many relationship, and optionally by introducing interface, by using the dependency inversion principle, we can reduce the coupling as well and make it easier to reuse the components.